Right done. There are two problems. Number one, a hexagonal plate of side 40 mm is resting on one side in HP, comma, parallel to VP, and 25 mm from VP. The opposite side, the side opposite to side in HP is in VP. Draw projections. A hexagonal plate of side 40 is resting on one side in HP parallel to VP and 20 mm from VP. The side opposite to side in HP is in VP. Draw projections. And second problem, a pentagonal lamina of side 30 is resting on one side in HP making 45 degrees with VP, having one end in VP. Draw projections if adjacent side is in VP. So pentagonal lamina of side 30 resting on one side in HP, making 45 degrees with VP, having one end in VP of that side. Draw projections if adjacent side is in VP. Now here we are going to start with the new part in projections of planes called as auxiliary planes. Auxiliary planes. And these two problems actually cannot be solved by the usual technique. Observe that in both the cases they have not given us the angle made by the plane. It is not there only. Whereas these two problems are so peculiar that for the first time we are given, in this case, the distance of the side from VP, which was never given. We could take it anywhere, right? But here it is mentioned. Whereas in the second case, he is fixing that particular side in HP because it should make 45 degrees with VP and one end should be in VP, right? So the initial orientation of the first problem is going to be, I'm going to draw it a bit smaller. If I am to keep this particular lamina, one side is in HP, I will have to keep it in HP only. But while drawing it, I will have to measure 20 millimeters, 25 millimeters, and then draw that hexagon with one side parallel to VP. There is just no other way by which this particular problem can be started, because position itself is fixed, so you don't have that freedom that I can place it anywhere, and obviously the lamina will be like this. These are A, B, C, D, E and F, and of course these will be the points A dash, B dash, C dash, D dash, E dash and F dash. Now the question is of rotation. This particular side should remain in HP and 20 mm from it, so we will have to rotate about it only. And this side BC, FE should remain in HP and BC should go to VP. Now this rotation, when it is trying to rotate keeping it parallel at fixed distance, and if I am to rotate it like this, the rotation cannot be seen in the front view, it has to be seen in the side view. So we do one construction here. We draw one more line which is nothing but the auxiliary plane, and it is auxiliary vertical plane. Because the lamina is in HP, its rotation cannot be seen in the front view, so I will try to see it in the side view. In side view it can be rotated, and so this is the auxiliary vertical plane that I am drawing, and I will take all these points parallel first of all, and then rotate them about this point. And so I get F dash, E dash here, this will be A dash, B dash, C dash and of course D dash, and this is the point about which I should rotate. So in the side view I can rotate it, okay, and this is vertical plane in the side view. This is the vertical plane in the side view, so I will have to take this as the center now. Take this distance in the compass and rotate it. So that B dash, C dash will be in VP and A dash, D dash will be here. So first I have got the side view. I can see the rotation. This is of course angle made by the plane with HP. And this will be angle made by the plane with VP, and theta plus phi will be 90 degrees. Now rotation in one view. Now where is the rotation? It is the rotation in the front view actually. So movement parallel to XY in other. So I will have to take these points down. See the procedure. I will have to take these 2 points down and rotate them back. See, here I have taken them to the side view. So this was the rotation that I had, and for this was the center. Then I have rotated about F dash, E dash, so this is my next center. After rotation I got the points. Now I am coming back and going here. Now F dash, E dash will maintain their position FE. A dash, D dash have moved here. They will now occupy the positions like these, because it is movement parallel to XY, and B dash, E dash will now go here, and I can complete the plan. This is going to be the final plan, and so FE has not at all moved. Now obviously all the points, they will lie on the respective projectors, and their heights are known from here. So B and C points, they will be these two positions. A and D are here, and FE will be here, and this will be the elevation. So this will be A dash, B dash, C dash, D dash. This will be E dash and F dash after rotation. This particular problem cannot be solved otherwise. There is no way. Okay, we can't take the line of rotation initially perpendicular. So there are a very few problems where there is an exception that you will have to start in a particular manner. Now the second problem that we have is having again you have taken down the problems. So in the second problem we have the pentagonal lamina which is kept in HP, one edge is in HP and its corner should be in VP, and that edge makes 45 degrees. So we will have to start the problem by drawing a 45 degrees line. What was the side of that pentagon? 30. So we take one point here, measure 30 millimeters and draw the pentagon right over here. So again is the case where the line of rotation is not going to be perpendicular to XY, but it is going to be somewhere else. And this point is in VP. That is, everything is fixed. We can't move from here. So I keep this point as A, B, C, D and E. Now keeping the lamina in this manner, if I am to rotate it, then rotation cannot be seen in the front view because it is not a line view. It will be something else that we can see. So again, like in this case, we should take a plane perpendicular to it, because what is the policy? So I am taking a plane perpendicular to this AB, line of rotation. Our all other problems say that line of rotation should be perpendicular to XY. Our line of rotation is fixed. So we take XY perpendicular to it, is the concept. This was again another XY. I could have drawn the same thing over here also, but that is difficult. Side view is easy to imagine. Here, now this is my problem. This will be my X1 and Y1. This is X and Y. So I am looking along the line of rotation. Obviously all the points will appear. Now this is going to be my HP that is seen. All the points are in HP. So this is going to be A dash, B dash. This will be C dash, D dash and E dash. So far so good. Now what he wants us, about A dash, B dash we should be rotating it. Now how far we can rotate? Because there is a limit. When we rotate, it is likely to cross even VP also. But what he is saying is the adjacent side, that means AE, should be in VP. If the line is in VP, its plan must be on XY. Now I start rotating. What will happen? All the points will start moving parallel to the new XY. All these points will start moving parallel to the new XY. And where should it stop? When point E also reaches XY, it should stop. Because AE, plan of AE should be on XY. AE is going to be in VP. So we should rotate till the point E reaches original XY. So we found how much E should move. So from there, we draw perpendicular, and from A dash, B dash till this C dash, E dash we rotate, because if we rotate it like this, this is where E dash should go. So I am going from here to this and from here till here, because E should be in VP. A is already in VP, So AE will be automatically in VP. Once I get this, I join A dash E dash and extend, and this will be rotated further onto it. To get point D dash. And of course this is going to be C dash. So I have taken this point, extended it, then rotated, I got point E dash, extended it, and onto that I got D dash. Now procedure remains the same. Take these 2 points down. So this will be new position of C, and take this D dash, and this is going to be new position of D. We just take them down. So this is new D, and the new plan will be like this, satisfying both the conditions that AB remains in HP, where adjacent side AE has now moved to VP. Got it? And now we should draw projectors through all these points. And take the distances from this XY. So A dash B dash are here. So this will be A dash and this will be B dash. For C dash and E dash, this is the distance from XY. So take that distance from C, from XY, mark it. So this is C dash and this is going to be E dash. Whereas this much is the distance of point D dash. So this distance I have taken and marked from this XY. And then if you join them, and he is saying one corner is in HP and VP, so A as well as A dash is the same point. Distances are to be transferred from XY to XY, right? So these two problems are to be done by the auxiliary only. Got it? Any doubt? So what was given to us over here, this distance was 25. That was given to us fixed, so we can't help it. Here this angle was given to us as 45, so we have no choice but to continue with that. Got it? Do that. And this is angle made by the plane with HP, if they ask. You know in what direction this point problem is moving, so accordingly place it. This is pretty easy because it is in the side view. I suppose on one page you can do both of them. Right, done. A circular lamina. Circular lamina of diameter, circular lamina of diameter 60 millimeters, 60 millimeters is resting on one point of its circumference, one point of its circumference in HP. The lamina is inclined at 50 degrees with HP. 50 degrees with HP. Whereas the diameter through point in HP, diameter through point in HP makes 20 degrees with VP. Makes 20 degrees with VP. Draw projections. Draw projections. So now we have shifted from polygons to the circle. As one point of the circumference of lamina is in HP, we need to keep the lamina entirely in HP, and so we will have to draw that circle in HP, right? And we will have to divide that circle into 12 parts. And each part will be 30 degrees each. We need not draw those lines. You know how to divide the circle into 12 parts? Circle can be divided into 12 parts by taking the radius and cutting the arcs from all these 4 points. So it will be divided into 12 points. And these points are to be numbered. For our reference, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. And of course, initially the lamina is resting in HP. So all these points will be on XY. I am not numbering them on XY because that will be very crowded. So the lamina, this will be the line view. I will simply name this 1 dash and 7 dash. Procedure will still remain same. Angle made by the plane first. Plane is making 50 degrees with HP. So we will have to draw a line at 50 degrees. And this 7 will move here, right? So point 7 moves here, point 10 will move here. You are required to rotate all these points. So this will be 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash. Same is point 8 dash, 9 dash, 10 dash, 11 dash and 12 dash. This is the line view of the plane. Rotation in one view is movement parallel to XY in other. So all these points will start moving parallel to XY. So point 10, point 9 and 11, point 12 and 8, 7 and 1, 6 and 2, 3, 5 and 4. And one by one we are required to mark them. So point 7 was here, it has moved here and is going to come down, and this will be point 7. Point 6 and 8, these will be these 2 points. Points 5 and 9, in my case they are aligning but they may not. Points 4 and 10, points 3 and 11, point 3 and point 11, points 2 and 12 and point 1, and then we are required to join them by a smooth curve so that it will be an ellipse in the top view. So this becomes finally 0.7, and he is talking about this diameter 17, which is supposed to make how much? 20 degrees. So we are required to redraw this figure. Now while redrawing this figure, first of all, if that diagonal is to make 20 degrees, I should take 20 degrees line, and then onto this I should mark 17, but problem is that 17 is not the true length, whereas this is given as angle with VP. So we are required to take the actual diameter, true length, and cut the arc. So could be here. So this is 0.1. I get path of 7, and then take the apparent length that we have got and cut the arc. So we will get the angle made by the plan with XY, and this becomes 17. So all this entire lamina is to be lifted, this ellipse, and to be drawn here. Now for that, the construction will be, you will have to draw lines perpendicular to 17. In this case, that arc technique will not work. It will be better if you move with the rectangle. That will be easier as well as faster. So I have just drawn lines perpendicular. Now from 1 till this point, topmost point, I take the distance and mark it on both sides. And I complete that rectangle. Then this point to 2 and 12, they are at this much distance, so I mark those 2 points. Then points 3 and 11. So all these lines I have drawn. Then take the midpoint of it, or you can choose this distance, which is the midpoint. Mark it. Draw that line. Then take the distance of again 4 and 5. If you have extended this till here, this distance equal to this distance, mark it. Draw those 2 lines also. And finally this much distance, so mark. And so you will get a mesh like this here. And now the job is simple. From here, this will be the next point, next point, next point, next, 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 here, this, 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 this. We get the 12 points, and we have rotated it in this direction, because 17 is now like this. So this will be 0.2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12, and we are required to reproduce the same ellipse. in the top view, right? And now the elevation is to be completed, so it is better if we go point by point. Point 1, path of 1, we get point 1, 1 dash. Then projector through point 2, and 12 up to 2 and 12, and so we get 2 and 12. Then projector through point 3, and 11, or you can draw all the lines, but there will be so many lines that there can be confusion, so I am avoiding that by going through point by point, and so I get 3 dash and 11 dash. Then point 4, and point 10. 4 and 10 will be here. Point 10 and point 4. Then point 5. And point 9. So 5 and 9. Point 5. And point 9. Then point 6. And point 8. Point 6 and point 8, and finally point 7. And point 7. And then we are required to connect all of them again by a smooth curve. And we complete the projections. The construction should be visible. It's a time consuming problem because 12 points and so many lines. Now here is the skill that you need to use that roller scale very properly, because all the lines should remain parallel. If they move, just change the angle even by half the degree, there will be chaos, right? Do it. If you want, you can take the diameter to be slightly bigger, whatever, but still it is okay. 60, 80 is the, they can ask you in the exam. Okay, do it.